On this next part of our series on fraud detection, we will be using an outlier-based classification approach called Quantiles. As covered previously, the typical way of detecting such a fraudulent transaction is by detecting an abnormally large amount of money spent, a different transaction location, or both. Based on this data, the bank or the system will determine whether or not the transaction is suspicious. For this part of our series on fraud detection, we will address our use case by using the quantile method of classification for detecting suspicious transactions. As we are using an unsupervised algorithm this time, a labeled dataset is not necessarily needed. However, we still need it if we want to grade our model. To train our model to classify transactions, we have implemented this workflow that reads real credit card data from our previously used Kaggle dataset credit card fraud detection. We do some minor pre-processing where we change the target column from 0 or 1 to the relevant meanings of good or suspicious. We apply the z-score normalization on all the numeric columns to help standardize the scale of the features in our dataset. And it also helps in identifying outliers better. Now, here's where we remove our non-outliers. You may wonder why we remove non-outliers or the typical transactions. This is because we are training a model on the outliers, or more accurately, the suspicious transactions to flag as potentially fraudulent. After removal, we can run the model on our data by passing them both to the mark outliers component. Inside this component, we partition the data into two categories. The top port are the outliers and the bottom port are non-outliers. From here, we can combine the results and check the score. On the next slide, we will go more in depth on the performance of the model. If we are satisfied with the performance, we can go ahead and save both the models by writing it to the disk so we can use it for our deployment workflow. Here's the view of the scorer node. We have a confusion matrix that shows the overall performance of the model. We can see the correctly classified transactions and the mistakes. At the bottom, we have an overall accuracy of 83%, which is to be expected due to the nature of the technique we are using. In comparison with other models, this is at the lower end as quantile classification is more suited to linearly distributed data, which is what we do not have for our case. Here's the next workflow we can use to deploy our trained model on a new transaction. On the left, we can read in our two models we saved and the new transaction. Next, we normalize the transaction based on our previous z-score normalization we saved. We then apply our model on the transaction and follow the same process shown before that we used in the training workflow. From here, if we open the component at the end, we can see that our transaction was not classified as fraudulent. If it was, the bottom port will open on the case switch node to send an email. You can download these workflows on the Knime for Finance space under Audit and Compliance. Feel free to check out the other techniques used for fraud detection.